I'm Dave Marshall. I'm Dave Development on the internet. I work for a company called childcare.co.uk, and I've recently started podcasting at thatpodcast.io. My co-host Bo is actually talking on the other track after this, so you should check his talk out. I'm not too close to the Symfony community. Most of my ties are through Silex. I tend to help out with the Silex community a lot. The reason I'm here today to talk is in 2001, mock objects were introduced to the world via a paper by some clever chaps from London. And in 2004, Martin Fowler wrote an article called Mocks Aren't Stubs. And basically what had happened was people read the paper and they got an understanding for it, but then they started calling everything a mock, and everything was mocking. And it's not really what the original chaps intended. So the terminology is not that big a deal. Tony said it irks me. It doesn't irk me too much. I say mocking for everything, just like a lot of people do. But I also do have an understanding of the actual types that do exist, the stubs, the fakes, the dummies, the spies. And I think everyone should have an understanding of those. So the talk's going to talk a little bit about terminology. We're going to go through the types of test doubles. And then we're going to have a look at testing behavior or state, which is kind of how your workflow changes based on what sort of doubles you're using. And then some bigger examples if we've got time at the end. So not only is the confusion that people call everything a mock, but also when they do try and use the proper names, they also get confused. Or not maybe confused, but they have different ideas of what a stub is, what a spy is, what a fake is. So for the purposes of this talk, I'm going to be using the definitions as laid out by a chap called Gerard Mezzaros, I'm not sure if I'm pronouncing that right, in a book called Eggs Unit Test Patterns. I can't really recommend the book, it's huge, I've barely read any of it, but there is a companion wiki, so you can look things up on there. I would highly recommend this book, which will cover all of the concepts I'm going to talk about in much greater detail. So an example of the confusing terminology, Mockito is a mocking framework from the Java world. And its tagline is, Mockito is a mocking framework that tastes really good. If you then go to the FAQ, one of the first or second questions on there is it really a mocking framework? And they say, no, it's not. Technically, it's a test spy framework. And then if you look at the API, the mock method creates spies, because it's a spy framework. But they also have a spy method that creates real spies, which I'd actually call proxied or parcel spies. So when I'm talking about some of these things, I'm going to be using a few terms that Gerard Mazzara is using in the book. System and the test you're probably familiar with, the thing we're testing. Dependent on component is something that the system under test uses or requires to operate. Indirect output. So this is some information or message that is going out of the SUT to one of its depended on components. So in this case, we're giving the repo a command. Indirect input is like indirect output, but this time the SUT expects to get something back from the depended on component. So the real meat of what we're talking about test doubles. And a test double is a replacement for a dependent on component that we're going to use to help either enable in the first place testing, ease testing, or just improve testing. It might be that something's non-deterministic, it might be that something's hard, it might be something's really slow to test. It may be that we're just going to use a double to make our tests more clear, so they show the intention of the test. One of the misconceptions is that we'd use test doubles to actually isolate the SUT from other parts of the system, and that's actually a side effect. It's not something we don't use test doubles just for that, or you shouldn't do. So creating test doubles, there are two different ways of doing it. The first way to do it is hand to build them, is to write the test double yourself, as in write the code. It gives you a lot of control. It can be a little less daunting for people because using tools, they're a bit magical. Uncle Bob Martin, who Marcella mentioned this morning, he says he writes all of his test doubles by hand. He has a fancy IDE. Who uses PHP Storm? Quite a lot of people. I'm told if there's an interface, you can right-click and say, give me a concrete class, and then he just has to fill in the bits to make it a test double. I don't use an IDE, so I don't really know. I tend to use generated doubles. Now, this is where you're going to use a framework to generate test doubles for you. I find they're quicker. I don't have to write any code. And I don't use an IDE. So and one thing I find with the test doubles that are generated for you, the DSLs for the libraries are usually pretty good. And I think that usually, if you use them properly, it's quite clear what you're trying to do and why you're doing it in your test. There's a bunch of tools for PHP. The first 5 are for doubling objects, methods, functions, and things. I'm only going to talk about the top 3 and not going to go into much detail. If you're using PHP unit, it comes bundled with PHP mock objects. If you're using PHP spec, it comes bundled with Prophecy. If you're a bit of a cowboy like me, you might use Mockery. Full disclosure, I maintain Mockery. The other 2 I don't know too much about. I know Aspect Mock is really magical. It uses auto-loading to point cut things, so you can mock anything. And the last one down there is a bit of an infrastructure type thing, which I'll show later. So this is a small bit, but test doubles can be configurable. Now, if you're handwriting them, they're less likely to be configurable, but the ones that are generated for you are configurable. And what I mean by that is you can, when you're setting up your test, you can configure those doubles in order to control the test, control the execution path, and so on and so forth. So, 5 types of test double in the title of the talk. I'm going to go through them in this order. Dummy is the simplest type of double there is out there. We use it when we need to satisfy a method or a constructor argument, particularly when it's type hinted, but it's not actually going to be used in the test. So in this example, this is a bcrypt password encoder from Symfony. The first thing it does when you ask it to encode a password is it checks to see if the password is too long. If it is, it throws. Now, as you can see, there's a second argument to this, the salt. That's not going to get used if we're testing this execution path. So when we're actually testing, we can actually give a dummy. Now here I've used a very expressive dummy salt that will not be used. It makes it quite clear in the test that it's there, but it's not going to be used. We call this a self-describing value in testing. It's a good habit to have for all testing, not just when you're using a dummy. Dummy objects are a little bit more complicated. So this is an adapted version of authentication provided from Symfony. It requires an encoder interface in the constructor, but when you're checking authentication, if you give it a blank password, it's going to throw an exception. So it's obviously not going to use the encoder, and it's not actually going to use the user either, but we'll ignore that for this example. A hand-coded example. I've actually taken the time here to write a password encoder that is a dummy. It implements the interface, and then if someone tries to call it, it actually throws an exception. This isn't absolutely necessary. You could use a null object pattern here and return null. However, it is a dummy and it's not supposed to be used. So particularly when you're hand coding one and it's going to go into your code base, it's better to throw. That way, if by configuration or something it ended up in production, we'd actually get exceptions rather than just nulls, which are obviously quite hard to find. Using it, quite simple. We just inject it where we would have injected the actual password encoder, and off we go. Using a testable framework, it's exactly the same really, but this time we haven't hand-coded anything and we're just going to inject a dummy from PHP unit this time. However, by default, PHP unit will give you a null object type double, so any calls to like encode password would actually return null. But if you use something like Mockery is slightly different. It will throw exceptions by default for any method calls. So Mockery is kind of more true to the specification of a dummy in this example. Fakes. Fakes are a little bit more complicated, more to get into. Now the emphasis with a fake is it is an implementation of what you're trying to replace, but it should be more lightweight, it should be faster, it should be more simple, and it can really, really help with testing. They can be used at any level of testing as well, unit, acceptance, integration, and you actually find yourself using them more in those acceptance or integration tests. Really, really simple example. I've not tried this on a big Symfony application, But just swapping out your database driver for a SQLite, an in-memory SQLite database, can make your test obviously run a lot faster. You know, set up, tear down will be quicker, actually exercising it will be quicker. It can make provisioning a test environment a lot quicker, or a lot easier. And it also means you can actually probably run your tests in parallel, you know, because it's in memory, it's in process, you don't need separate MySQL instances, etc. Fake objects, like the dummy we just talked about. Back with the authentication provider, Symfony actually has a plain text password encoder, which doesn't actually do any encoding. It, you know, just returns the password that you give it. So in using this, our test is a little bit more clear. We don't have to worry about putting some sort of bcrypt value into the user. We just pass it in, just like we did with the dummy, and our test should pass quite easily. One thing that's worth noting is you do have to require some knowledge of the system, in that so we've coupled slightly, and we need to know how that password and salt are merged together. So it's a slight drawback. Another fake object that you might not realize is you're using quite often. When you're using the test, or the default test environment for the standard edition, it actually swaps out the session storage for a mock file session storage. It's not a mock, it's a fake, because it does stuff. But that allows you to run PHP Learn and let you start and stop a session once within a process. So when your tests are running, you can start, stop as you go. Fake web services. These are a lot more complicated. Web services can be very difficult to test, integration test with web services. Obviously, depending on the network connection, which could be temperamental or just not there if you're on the tube or something. Difficult to control, to arrange your test, to set up fixtures. So it can be good to use a fake web service for your integration test. You could try and do this using objects. You know, if you've got a well-spec'd API client, you could replace the API client with a fake. But another option is to actually develop a fully blown fake web service. I did this at childcare.co.uk for our payment processor, which is Recurly. It wasn't easy to tear down their sandbox API, and it also wasn't easy for me to set up fixtures where I might have needed somebody who, you know, joined us a month ago and will build 3 times or something, and I need to work on that. It's kind of hard to set up with their public-facing API. Having done that, I probably wouldn't go to the effort again, but I'd probably, because I feel comfortable now, and I'd just skip those tests that were really hard. But it's been working for 2 years, and tests are running daily, you know, so no real complaints. And this is a bit of a strange one, but can you have a fake using a test double? Now, fakes have to have an implementation, they have to have logic. Now, this is from PHP units documentation. Now, they're saying, you know, stub this class, and when they call do something, I want to recall rot13 of the past string. That's logic to me. You know, it's not a stub. It is kind of a canned response for a finite number of values, but it's not very clear in the example. So in summary, like fakes, usually hand-coded, but you can use a framework if you're going to mess about with closures and things. The nice thing about fakes is they provide low coupling between the system under test and the actual test itself. The other thing is they might need to expose state to help you verify what's actually changed or what your SUT has actually done. And they can get really complicated to maintain. On the other hand, while they can be complicated to maintain, there can be instances where the fakes actually become the real implementation. Going back to Uncle Bob Martin, he talks about fitness when they were developing that. They were going to use MySQL as a database, but to get them started, they just started with a file system storage with full intentions of writing the MySQL version later. And it actually got to the point where they were just actually happy with the file system storage, and they shipped with it. They didn't bother with the MySQL. So the fake was a fake to start with, but actually just became the real deal. Stubs. Stubs are literally just there to provide canned responses to the SUT, nothing else. It can be objects, or they could be systems, you know, high-level things. Really simple example, an object. We're going to create a stub, a double of the employee repository, and we're going to stub out the method find that when it receives the ID 123, will return an employee. It's quite easy, quite simple. That was using PHP unit. Yeah. Something a little bit more interesting for a stub would be HTTP calls. Anyone uses VCR for Ruby? Yeah, did you know there's a PHP VCR? It's quite in quite an early infancy sort of stage, but it's come along quite nicely. So what we're going to do here is we're going to tell our test that we're going to use a VCR. We're going to tell it where to store it. We'll say the example, insert cassette example. And what it'll actually do is it hooks into the stream handling, I think. So when we call file get contents, it'll obviously return the result as normal, but it'll also record that result in a file, in a fixture, if you like, on the file system, so that next time we run this test, instead of actually going out to HTTP, it'll load the response from the file on disk, and you can make your assertions against that response. So this would be great for, like I said, running tests on the tube. You can have continuous integration. You don't have to worry about any network problems. And the really nice thing about it is there's like a configuration script that says, don't bother with the fixtures that we've got saved. I want to rerun the whole suite again, making those calls, and you sort of re-verifying that your integration tests actually work against the API. It's really cool. Like I say, it's in its infancy, but it's worth checking out. So mocks. Mocks are a bit more involved, so now we're getting more to the meat and potatoes of doubles. Introduced in 2001 by this paper called Endo testing, unit testing with mock objects, and they're used to verify the indirect outputs of the system under test. So in this example, I'm using Prophecy, and we're creating a double of the employee repository, and then we're telling the test that we're expecting the add method to be called on the repo. We're saying it should be called. We're exercising the SUT, and at the end we're asking it to check the predictions and make sure that those calls that we told it to expect actually happened. The very bottom bit there, the check predictions, most test frameworks have integration, so it'll do that explicitly for you. So they verify the behavior of the SUT. They can act as stub returning values as well, because we don't all do full CQS type things. And the problem with mocks is they can lead to over-specification and lead to brittle tests, and this is where they get a bit of a bad reputation. So I'm going to go into that in a bit more in a minute. When to use them? When you need to verify an outgoing message from the SUT that's not that easy to do by verifying the state of the system afterwards. For example, a cache. If you require your service to check the cache first before hitting the database, it's kind of hard for you to say, to check the state of the system at the end to see if the cache was tried or used, whereas with a mock, you can prove that. And the other time you'd use it is when you're doing full TDD and you're working outside in, and you're using it to discover new interfaces, and you're using it to drive the design of your system under test, which we'll talk about again in a minute. SPIES. SPIES are just like mocks, but instead of verifying the indirect outputs, they're just there to observe the outputs. So to switch from a mock to a SPIE is really easy. Instead of telling the double, the mock, what to expect, we switch it out to the bottom. So we create the double, we put it in the SUT, exercise the SUT, and then we say, you should have been called. So the SPIE observes the calls, or the method invocations, and then allows you to verify them afterwards. Nice implementations like Prophecy make it easier to verify. You can do spying with just PHP unit mocks, but it's almost like you have to ask it for the calls, and then you iterate over them yourself to make your assertions. There's no SPIES in Mockery yet. I've kind of done the implementation, I just haven't decided on the final API yet. So, record the interactions, allow verification afterwards. The nice thing about SPIES is they give us back this more familiar workflow of testing when we go through, you may have heard arrange actor set and given when then. So rather than given this stuff, I expect all of this to happen. When it happens, then I want you to make sure it happened, the stuff I told you happened. It's a bit, it's a bit strange with using mocks. And because of that, the tests can reveal a bit more intent. And also with SPIES, you can hide irrelevant calls because you're not telling. With a mock, you have to tell it everything that you expect to happen ahead of time, whereas a SPIE will kind of just listen to what happens, and you only have to ask it about the specific things you care about. The only thing with SPIES is that debugging can be harder. So if I've told a mock to expect a call to add the add method with 1, 2, 3, and it gets 4, 5, 6, it will throw an exception at that time, which will give you a nice stack trace, which will lead you back into the SUT to where the call happened. Whereas with a SPIE, it's more like, nah, that didn't happen. Go find out yourself why it didn't happen or where it didn't happen. When to use them instead of mocks, if you'd like to. If you feel like it makes your tests more readable, which is a really good reason. One very good reason would be if you can't predict a value ahead of time. So if you can't predict and tell the mock what to expect ahead of time, you're better off using a SPIE. And the other one's a bit of an edge case. If your system under test swallowing exceptions, which is how most mock frameworks report failures, so a mock wouldn't be any good to you. You'd have to use a SPIE and do it after the fact. So test first or test last, we're going to talk about a bit more about how you might use them now. Does anyone do full TDD, like test first, yeah? Does everyone else just do test last? Everyone is testing, right? I do tend to do a lot of test first. I really like it, and I personally don't feel like you're getting the best out of test doubles unless you are doing test first. But I'm not into a holy war, like the TDD is dead kind of worms thing. What is more important is if you're testing state or you're testing behavior. I mentioned them all already. You can do both, test first or test last. You can do state or behavior verification, doesn't matter. Again, holy war. People who test state are often called classicists or statists. People who test behavior are often called mockists. I don't really believe in it myself. I don't think there's any verses. As far as I'm concerned, most mockists do everything the classicists do anyway. They just do a little bit more on top. And you don't really get many mockists writing, classicist testing sucks, whereas you do get it the other way. So it's a bit, I don't know. Verifying state then. So when we're verifying state, we're going to exercise the SUT, and then we're going to assert against the state afterwards against our expected state. So this usually involves stubbing and faking, but no mocks or SPIES. We always use the public API first if we can, so try the front door first. Unfortunately, that's not always possible, and sometimes you have to put code into production code just to enable testing. It's usually getters and things like that. So just to be able to assert that something's happened, which is a bit unfortunate, but part and package of what you're doing. Can require a lot of fixture setup at the beginning. So setting up your test, arranging your test can be quite difficult. And they don't talk about this much, but I feel like when you're testing state, your test can become coupled to the system as a whole quite easily. I mentioned you had to know how that password and salt will merge together. That's coupling to me. I'm not all that keen on it. And the other thing about when you're verifying state, usually means you're kind of doing a little bit of integration testing. You may not feel like it because you test quite fast and you're only using objects, but you're using several objects at once usually, using fakes or just the actual real components anyway. And when bugs happen, you can have a rippling effect, and a change or a bug in one part of the system can actually cause a lot of tests to fail that are unrelated, which makes it harder to track down. So my personal favorite, verifying behavior, is when we're checking those indirect outputs of the SUT. So we're testing from inside the SUT using mocks and SPIES. And its intended use is as a design methodology, first and foremost. The actual tests are an artifact that come out. The verification is something that comes out of the process. This allows us to do what's called need-driven development. So we're writing our test, and as we're writing the test, we're actually describing what our system under test needs in order to work. And the nice thing is you carry on writing that test, and then you write the SUT because you're using doubles, and then later you can go back and actually write the actual implementations of those things. And it's a much more improved workflow for me than having to go work middle out, as they call it, where you have to, if you decide you need something, you have to go build that thing first, then come back to what you're actually doing. As a side effect, we get the isolation, so bugs are much easier to track down when they occur. Encourages information hiding. We don't have to expose information through getters and whatnot in order to make assertions, which is a very OOP thing to do. Unfortunately, there are a lot more gotchas and a lot more sort of bad practices that have come out of mock objects and things, and that gives it a bit of a bad reputation. And the biggest problem is leading to a high amount of coupling between your test and the SUT. And effectively, the test is almost repeating the actual production code. But there are ways to avoid it, which I'm going to talk about in a minute. So one of the things is precision. And by precision, I mean specifying in your test how many calls, what calls, the order of calls, whether to expect the exact arguments or not. And the more specific you are in the test, the less flexibility you have in that test, and the more likely you are to break tests when you refactor, tests that are irrelevant to the actual bit you've refactored. And it's really hard balancing act. And the more precision you have, it can also just make your test look a bit noisier, make it a bit harder to read, make it a bit harder to actually show what you're intending to do with this test. Now, one way to sort of get over it is to think, when you're actually writing your test, you need to be thinking, is this a required behavior? What I'm writing here, is this required to make the test pass? Or is it required for the SUT, is it to do its job? Or is what I'm writing here an artifact of the actual implementation? Am I having to put this in my test just because of the way something's written? So, because I work on mockery, I get asked quite a lot of support questions and things. And this is a good example. I was asked to debug this with someone. In there, there's 16 mock objects, 18 method expectations. Now, the first thing I'd say is that the system and the test are probably doing way too much. But there are sort of smells that you can do. You know, you're clearly mocking too much, and it's going to cause problems. So the first thing is don't mock values. We do not mock value objects. There's no point at all. If your value object should be immutable, so it's not like you need expectations. We don't need to say the system and the test called get domain 3 times. We don't care how many times it said get domain. And it's usually just easy enough to create them, use them. Next one would be not to, and I say try not to, because it's not a golden rule for me. Don't mock concrete classes. One of the problems is when you mock a concrete class instead of an interface is it kind of hides a relationship between the system and the test its collaborators. When you have an interface, it shows clearly the relationship between the SUT and the collaborator. Whereas with a class, you're kind of showing that whole API is a relationship. So the whole API of this class is the relationship between these 2 objects. And I take this a step further, and I actually do this with entities as well. I mean, it's really hard to describe an interface for an employee quite often. There might be some specific instances, but generally when I'm working with entities, like your doctrine entities, I just want to work with the entity. I'm not going to create interfaces that they'll implement. But we still see people mocking them, and it's better not to. If it's hard to create the object graph for your entities, use something like an object mother. I have these everywhere in my test suite. It just makes it so easy to create them. If something like that's a bit too difficult, use builders as well. It can be really effective. Only mock types you own. Now, this came out of, I mentioned in 2001 they came out with the mock objects as a concept. I think it was like 4 years later they came out with another paper that was like, we didn't really mean it like that. And they said what they found was the real benefit of these mocks was as a design tool, and you can't design something that isn't yours. So if you're going to mock a third-party library, now you're not designing that third-party library, are you? Because it's not yours. You're not going to change it. So you should be mocking interfaces. You should be deriving interfaces for your SUT. So if your SUT needs this, you can describe an interface that gives it what it needs, and then you create adapters for those third-party libraries. to meet them. One thing is that I heard this from Gary Bernhardt, and he loosened it to things you trust. You all use the PSR logger interface, yeah? That doesn't belong to me, but I'm not going to write my own logger interface, if you see what I mean. So I consider that part of the standard library, I trust it, so I will mock it as I please. Another sort of really nice rule of thumb would be to mock ports. If you're familiar with ports and adapter as an architecture, if you stick to mocking ports, like so here, each side of the hexagon would be a port, and then we've got a doctrine adapter, a fake DB adapter. So if you stick to mocking these ports around the edges, that actually usually are an interface to the sort of infrastructure you need, you won't go far wrong. So a couple of examples I'm going to go through kind of quickly. The first one, this is adapted from the Symfony documentation about mocking out the database. This is the SUT, it's a salary calculator, uses an employee repository. This is the example they give in the Symfony documentation. There are a couple of things wrong with this. First one, they're mocking an employee, and they're mocking a couple of getters. So not only are they mocking it, they're expecting calls once. You're only allowed to call the getter once. I don't know why. But they're also, is it really necessary? Can't we just create an employee with a salary and a bonus? And then again, on the employee repository, is it a mock or a stub? Are they only allowed to call the find method once? Maybe they do. Maybe it's a performance thing, but it's not that clear from the test anyway. So I'd ditch that and get rid of that. So I'd have a test that looks something a little bit more like this. I'm creating an employee that gets paid this amount, makes it quite clear, I think. Ditch that expectation, so the employee repository double is no longer a mock, it's now a stub. And I'll test a little bit cleaner, and I think communicates the intent a little bit more. One thing to notice is in the example, they didn't actually pass an ID to this stub, which could lead to a false positive. Unless you've got an integration test or an acceptance test covering this, which you should, you might forget to pass the ID to the repository in the actual production code, and therefore things would not work in production. Another example, mocks and SPIES. This is sort of I made up example. It's to when you forgot your password. We're going to concentrate on this middle bit here. We're going to leave the email bit at the edges of the system. Maybe we're going to have a SMS version or something later. And we're actually going to do this need-driven development, so full mocking style. We're going to write our test first. We know we're going to need some sort of random string, so we'll create a double for a random string generator with a method called generateWithLength. It's going to return a string. We're going to create a mock this time for some sort of repository to store the token. We're going to pass them both to the system under test, and hopefully we'll pass. So having written that test, we know we've discovered these two interfaces that we need. Later on, we'll come back and write actual implementations of those. We'll use a database, no doubt, for the repository and something else for the generator. And our system under test looks quite neat and tidy. Excuse me. Switching to SPIES is actually really easy. We just moved this, we had this expectation up further up. We said the repo was expecting to receive the add method. Now we're just going to verify at the end that it received the add method. But the nice thing about the SPIES is we didn't know what the random string was going to be. So we couldn't predict ahead of time what that random string was going to be. Now we're doing it down at the bottom, we could, because the actual SUT returns that string. So we could change our test to this. Instead of passing in a string generator, we're just going to ignore that. It becomes an implementation detail. We get the token back out from the generator, the system under test, and we use the token to verify at the end, which makes our test a little bit clearer. And it also makes our system under test a little bit cleaner and easier. We're just generating a random number in the SUT. Yes, we've created some coupling here, but we've also removed coupling here because we're only depending on one dependency now, not the other. And I'd take this. It's not like I'm connected to a database or something. Last example. talking about strict or lenient mocks and the precision again. You should be familiar with this kind of thing from Symfony, persisting the user and then flushing the entity manager. Now, this would be an example for me of overspecification. We're telling Mockery to ignore missing calls on the entity manager. So in this case, it's probably going to ignore the flush, but make sure we've called the persist, which is great, but I don't really care about it. I just want it to persist the user. I don't care about having separate tests for flushing the entity manager and adding the user to the... So that's a form of overspecification to me. And that's with an extra lenient mock. Now, a lenient mock, we're going to specify that we expect both calls within the same test. But we might have a false positive here. It's unlikely to happen. But if we were to switch those persist and flush calls around, we'd have problems, wouldn't we? Because we'd be flushing the unit of work to the database, then adding our user, so it wouldn't actually get added to the database at all. To get around that, we could actually go with a strict mock. It's not something I do very often, but the tooling is there, and you can tell Mockery that you're expecting these calls in a particular order. And if they don't happen in that order, Mockery will throw an exception. So, last thing I wanted to say, none of the tools in the PHP the world actually make the kind of testable you're using very explicit, or make it explicit to show your intentions. So I'm kind of thinking for Mockery 1.0, when we ever get around to it, it's having an API a little bit like this. So I can make it quite clear in my test that this is a dummy. And methods, you can call methods, but you'll get exceptions, it won't work. Making it quite clear that this is a stub. You can't set expectations on this. You can only stub methods. This is a mock, and you can only tell it to expect things ahead of time. And this is a SPIE. You can only verify things after. And I kind of like this idea. I'm still playing with it, but I think it gives that kind of, shows you, makes it more clear in your test what you're trying to do. And if something changes, then you'd have to make sure you're changing your test to make it clear. So that's it. Sorry it was a bit rushed. I forgot it was a 40-minute slot until about 3 days ago. It's crammed everything now. If you've got any questions, I've got like a minute. And any feedback would be appreciated. So. Okay. Oh. Thanks, everyone.
Any questions? We can do one or two.
Not a question, but yeah, being able to explicitly say what kind of test double it is would absolutely make promote the idea of different styles.
Yeah, I like the idea. I mean, I say mocking and mock all the time, but I do feel like I understand. Well, I hope I understand it, because I've just tried to tell you. but yeah, and I think it would help. Anyway, if you use RSpec mocks, I think they do have this stuff. They keep the same sort of standard. I think they have a double method that will give you something that will do everything, but they also have specific methods as well, and it allows you to show, like I say, a bit more intent in your tests, which is what they're all about. So.
Yeah, thanks.
Thank you.